Good morning, everyone. Am I audible? Okay, in last class, what did we study? Last class क्या पढ़ा था हम लोगों ने? Manufacture of cement, dry process, wet process, isn't it? Okay, so we have studied chemical composition and box compound, isn't it? These are the box compound: tricalcium silicate, dicalcium silicate. These are the box compound: tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminum. Okay, so these are the chemical formula of box compound. That means these are the major compounds. Okay, and C3S, these are abbreviated formula. It is to be noted that for simplicity, Sheikh abbreviated notations are used. C for CaO, S for SiO2, A for Al2O3, and F for Fe2O3, and H for this. The oxide shown within the bracket present the percentage same in the raw material. So in addition to the four major compounds, there are many minor compounds formed in the rotary kiln. The influence of these minor compounds and the properties of cement of hydrated compounds is not significant. Two of minor oxides, namely K2O and Na2O, referred to as alkalis in cement. So, in the diagram, you can see there is a schematic presentation of various compounds in clinker in the manufacture of cement. Okay, these blue colored compounds are C2S. These blue color compound are C2S. These are C3 and C4AF, okay, and C3S. Tricalcium silicate, yes, there is some important works of this box compound, okay. Tricalcium silicate and dicalcium silicate are the most important compound and which is responsible for strength. Together they constitute 70 to 80% of the cement. The average C3S content in modern cement is about 45% and that of C2S is 25%. Can you see the abbreviation is used here? Okay, C2S, calcium silicate. The sum of the contents of C3A and C4AF has decreased slightly in modern cements. The calculated quantity of the compounds in cement varies greatly even for a relatively small change in the oxide composition of the raw material. To manufacture a cement of stipulated composition, it becomes absolutely necessary to closely control the oxide. An increase in silica content at the expense of the content of alumina ferrous will make the cement difficult to fuse and form clinker. Okay, the advancement made in the various phases in the sense of okay, these are not required. So mainly responsible compounds are tricalcium silicate and tricalcium dicalcium silicate, which is responsible for giving strength to the cement. So there is a Flow chart. Flow chart of how cement is manufactured, raw materials of cement, and components element are in raw material, oxide component, compound component, Portland cement. On hydration, these produce production of it. Another important topic is heat of hydration. That means hydration of cement. Okay. See, what is heat of hydration? See, hydration of cement means when we add water to the cement, when you add water to the cement, then it is called hydration of cement. Anything, if you add water anywhere, that is called hydration. Addition of water, hydration, isn't it? So hydration of cement is when you add water to the cement, that is called hydration. So anhydrous cement does not bind fine and coarse aggregate. So to form a bind to act as a binding material, cement should be chemically hydrated. Okay, so it acquires adhesive property only when mixed with water. The chemical reaction that takes place between cement and water is referred as hydration of cement. Okay, so this is the definition of hydration of cement. The chemical reaction that takes place between cement and water is referred to as hydration. Why it is a chemical reaction? Because cement is a chemical compounds are there in cement, isn't it? Silica, lime, all these are chemicals. That's why it is called chemical reactions. The chemistry of concrete is essentially the chemistry of a reaction between cement and water. On account of hydration, certain products are formed. These products are important because they have cementing or adhesive value. The quality, the quantity, continuity, stability, and the rate of formation of hydration products are important. Anhydrous cement compounds, when mixed with water, react with each other to form hydrated compounds of very low solubility. The hydration of cement can be visualized in two ways. The first is through solution mechanism. In the cement compound dissolves to produce supersaturated solution from which different hydrated products will participated. And the second possibility is mm, the water attacks cement compound in solid. Okay. So next is your heat of hydration. What is heat of hydration? So in this figure, in this graph, there is heat liberation from a setting cement. When water is added to the cement, some amount of heat is released. That quantity of heat is called the rate of liberation, calorie per gram, and this is the graph shown heat liberation in setting time, in setting cement. See, heat of hydration. What is heat of hydration? The reaction of cement with water is exothermic. What is exothermic reaction? Exothermic reactions are those which liberates, which produced a large amount of heat. Okay, that is called your exothermic reaction. The reaction is considerable quantity of heat. The liberation of heat is called heat of hydration. This is clearly seen if freshly mixed cement is put in a vacuum flask and the temperature of the mask is read at intervals. Suppose in a clear vacuum, suppose in a vacuum flask, if you add cement and water, then automatically the temperature of the flux is increased. That means there is something going on between cement and water. What is that? That is heat is produced. Okay. So that is your heat of hydration. The study and control of heat of hydration becomes important in the construction of concrete dams and other mass concrete construction. It has been observed that the temperature in the interior of large mass concrete is 50 degrees Celsius above the original temperature of the concrete mass at a time of place. On mixing cement with water, a rate of heat evolution lasting for a few minutes occurs. Okay, this heat of evolution is probably due to the reaction of solution of aluminates and sulfates. The initial heat evolution eases quickly with the solubility, and aluminate is depressed by gypsum. Different compounds hydrate at different rates and liberate different quantities of heat. Okay, as shown in the figure. So, the total quantity of heat generated in the complete hydration will depend upon the relative quantities of the major compounds present in the cement. So, in this figure, you can see the heat produced by different compounds. C3A4, C3A, C3S, and C2S. What is C3S? Marine. Sorry. Sorry. Actually, Navanta ma'am just entered in the room. That's why I told her like that. Okay? She entered in my class. That's why. Yeah, she interrupted my class. That's why I told him like that. I told her like that. Okay, so C3A4 compound, here liberation of C3A4 compound, heat is uh, very high as compared to C3A and C3. The low heat liberation heat of liberation occurs with C2S. What is C2S? Dicalcium silicate. Okay, these are the major compounds. So rate of hydration of pure compounds. The more heat is liberated due to which compound? C4AF. What is C4AF? It is your tetracalcium aluminoferrate. Okay, tetracalcium aluminoferrate. So this compound liberates more amount of heat. Have you understood? This major compound C4AF liberate more amount of heat as compared to other compounds C3S, C2S, C3S. Okay. So here in this table, it is shown the amount of heat liberated by various compounds. C3S liberation of heat is in 3 days 58 calorie per gram, in 19 days 104 calorie per gram, and in 13 years it is 122 calorie per gram. Okay. Since the heat of hydration of cement is an additive property, it can be predicted from an expression H equal to A. Okay. So the normal, let me mark the important one. Normal cement generally occurs 89 to 90 calorie per gram in 7 days and 90 to 100 calorie per gram in 28 days. Okay. The hydration process is not an instantaneous one. The reaction is faster in the early period and continues indefinitely at a decreasing rate. Okay. Complete hydration cannot be obtained under a period of 1 year or more unless the cement is very finely ground and reground with excess of water. It is also observed that complete hydration under normal condition is possible only for cement for particles smaller than 50 micron. Okay, the hydrated product of cement compound is a grain of cement adheres firmly to the unhydrated core in the grains of cement, that is to say unhydrated cement left in a grain of cement will not reduce the strength of cement. Okay. Okay. So next, there will be various types of cement. Okay. So actually, uh, I have given two notes, isn't it? That is related to chapter 1 and chapter 2. That is your core segregate chemical admixtures, limitation of concrete. First introduction part is given, and cement manufacturing process is given, isn't it? Okay, so we have various types of cement depending on the chemical formation, chemical constituent. Uh, so these are the types of cement, various types of cement. Okay. Number one is your ordinary Portland cement. Among ordinary Portland cement, we have three grades of cement. Okay, 33 grade, 43 grade, and 53 grade cement. And the IS code, which is which refer to the cement OPC 33. Okay, see, ordinary Portland cement in short form we call it as OP. Oh, sorry, OP OPC cement. Okay, so OPC 33 grade mean it follows these IS code. IS 269 1989. And for ordinary Portland cement, 43 grade, we use IS 8112 1989. And for ordinary Port OPC 53 grade, we use IS 122 69 1987. Another types of cement is your rapid hardening cement. Okay, and IS code is this one. And the IS code is this one. And next is your extra rapid hardening cement, sulfate resisting cement, Portland slag cement, quick setting cement, super sulfated cement, low heat cement, Portland pozzolana cement. Okay, Portland pozzolana cement we call it as PPC cement. Okay, PPC cement. It refers to IS code 1498 part 1 1998 fly ash based. So I will tell you later what is fly ash. Okay? And 148 fly ash I will tell you later about that this compound. Okay? This is actually cement like structure fly ash. And this one air entraining cement and colored cement, white cement, hydrophobic cement, masonry cement, expansive cement, oil well cement, reddish cement, concrete sleeper grade cement, high alumina cement, very high strength cement. Okay, so these are the various types of cement. These are the various classification of cement. And first one is OPC cement, ordinary Portland cement, OPC. In short form, it is called OPC. Is by far the most important type of cement. All the discussion that we have done on the previous chapter are more OPC cement. Okay. Prior to 1987, there was only one grade of OPC, which was governed by IS 269 1976. After 1987, higher grade cement were introduced in India. OPC was classified into three grades: 53 grade, 33 grade, 43 grade, and 53 grade. Remember, OPC has three types of grade. Okay, 33 grade, 43 grade, and 53 grade, depending upon the strength of the cement. What is OPC? Suppose I am saying OPC 33 grade. What does it mean? What does it mean? OPC 33 grade? That means this OPC cement has a strength 33 33 Newton per mm square. Okay? 33 grade, 43 grade, and 53 grade, depending upon the strength of the cement in 28 days. When tested as per IS 4031 1988. If the 28-day strength is not less than 33, then it is called 33. If the 28-day strength is not less than 33 Newton per mm square, then the cement is called 33 grade. Okay? And what about 43 grade? That means 43 grade cement has a strength not less than 43 Newton per mm square. And if the strength is not less than 53 Newton per mm square, it is called 53 grade cement. Okay, but the actual strength obtained by these cements at a factory is much higher than BIS specification. BIS means Bureau of Indian Standard specification. The physical and chemical properties of 33 grade, 43 grade, and 53 grade OPC cement are shown in the table. Let me show the table. These are not sorry. Table 2, physical and chemical provides a table 2.5. Which one is table 2.5? Let me show you table 2.5. Yes, this is a table. Oh, it is like this one. So these are the physical characteristics of various types of cement. Okay. Physical characteristics of various types of cement. As I told you, we have 33 grade, 43 grade, and 53 grade, isn't it? Fineness, soundness, setting time. So in setting time, there is two setting time. One is final and one is initial. And compressive strength, 1 day, 2 days, 7 days, and 28 days. So actually, setting time and compressive soundness, these can be tested. The cement tests are fineness test, soundness test, setting time, compressive strength test. Okay. Okay. So another type of cement is next one is the manufacturing of OPC is decreasing all over the world in the view of the popularity of the blended cement on account of the lower energy consumption. So generally OPC production is lower nowadays. One of the most important benefits of this type of cement is faster rate development, faster strength development. Okay. Although they are little costlier than low grade cement, they offer 20 to 20% savings in cement consumption, and also they offer many uh, other hidden benefits. One of the most important benefit is faster rate development of strength. In the modern construction activities, higher grade cement have become popular. That 33 grade cement is almost out of the market. Okay. Okay, next one is your rapid hardening cement. The detail of testing methods. So cement test we will study in the next chapter. Okay. So next types of cement is rapid hardening cement. And what is the IS code? If the IS, why some are joining now? Some students are joining now only. Why? I have given on one time, na? So I will give one attendance to you. I have two classes, so I'll give one attendance to those who have joined later, who are joined late. Okay, so rapid hardening cement, this is similar to OPC cement, but the name shows that rapid hardening cement. That means the rate of development of strength is more years. Rapidly develops strength. As such, it may be more appropriate to call it high early strength cement. It is pointed out that rapid hardening cement, which develop higher rate of development of strength, would not be confused with weak setting cement. That is another type of cement. Rapid hardening cement develops the age of 3 days, the same strength as that of expected ordinary Portland cement at 7 days. So when we use ordinary Portland cement, the strength development time is 7 days. Whatever strength developed when we use OPC cement in 7 days, that much of strength is developed by rapid hardening cement within 3 days. Have you understood? So rapid hardening cement is more faster strength development occurs in when we use rapid hardening cement. So a higher fineness of the rapid rate of development of strength is attributed to higher fineness of binding specific because it has higher C3S and lower C2S content. Okay. What is C3S? Can anyone tell me? Can anyone tell me what is C3S?
Tricalcium silicate,
Tetracalcium? Tetracalcium or
trical,
tricalcium
tricalcium,
silicate? Okay. The finer fineness of cement particles expose greater surface area, isn't it? Remember this line. The higher fineness of cement particles expose greater surface area as action of water and also higher proportion of C3S results in weaker hydration. Consequently, rapid hardening cement gives out much heat of hydration at early stage. Therefore, rapid hardening cement should not be used in mass concrete construction. Why? Because it produces more heat of hydration. The use of rapid hardening cement is recommended in prefabricated construction, concrete construction, where formwork is required to be removed early for reuse and road repair works. Generally, rapid hardening cement is used in road work. Okay, in road work. Why? Because road should be uh, attain its strength quicker, isn't it? So that the vehicles can run along a road. That's why in road we use rapid hardening cement. Repair of roads. In cold weather concrete where rapid rate of development of strength reduces. So in cold weather or in cold areas like Himachal, Jammu Kashmir, this type of areas we can use rapid hardening cement. This type of cold places. Okay, the physical and chemical requirements of rapid hardening cement. Okay, so there is another table for rapid hardening cement. Next is extra rapid hardening cement. Extra rapid hardening cement is obtained by intergrinding calcium chloride with rapid hardening Portland cement. The normal addition to calcium chloride should not exceed 2% by weight. So rapid hardening cement if we add 2% calcium chloride, 2% weight, then it is called extra rapid hardening cement. Okay. It is necessary that concrete made by using extra rapid hardening cement should not be transported, placed, and compacted and finished. Okay, should be transported, मतलब यहाँ सीमेंट कंक्रीट जहाँ पे बना रहे हैं, from that we have to transport, placed in the construction part, structure part, compacted and finished the whole work within 20 minutes. It is necessary that a cement should not be stored in more than a month. ज्यादा ज्यादा दिन तक सीमेंट स्टोरेज करके we don't use that type of cement. Okay, not after a month. What will happen? The cement is um, cement loses its strength, loses its react with air, and ultimately it loses its strength. That's why we cannot use cement which is uh, stored more than a month. Extra rapid hardening cement accelerate the setting time and hardening process. A large quantity of heat is evolved in very short time. Acceleration of setting hardening cement. Okay. This type of cement completing of suitable for cold weather, as I have told you in Jammu, like places, Himachal Pradesh, Jammu, cold places. The strength of extra rapid hardening cement is about 25% higher than that of rapid hardening cement. Okay, this is some evidence that there is a small amount of initial corrosion or reinforcement or extra rapid hardening cement is used, but in general, this effect does not appear to be progressive and such there is no harm in use of extra rapid hardening cement. In Russia, the attempt has been made to obtain the extra rapid hardening support by grinding the cement to a very so Russia is a very cold place, isn't it? So in that cold places, we can use extra rapid hardening cement. Very fine degree to extent of having a specific surface between 5,000 to 600 square centimeter per gram. Okay. Next is sulfate resisting cement, and the IS code which specified this cement is IS 12330 1983. So sulfate resisting cement is that type of cement which resists the attack of sulfates. In particular to the action of magnesium sulfate reacts both with the free calcium hydroxide in cement to form calcium hydrate and hydrate the cement aluminate to form a calcium sulfoaluminate. Okay. Solid sulfate do not attack the cement compound. Sulfates in solution permeate to hydrate the concrete and attack calcium hydroxide, hydrated calcium. The above is known as sulfate attack. Okay, so there is an expansion in the framework due to the reaction with sulfate present in a cement. Sulfate attack is generally accelerated if accompanied by alternate wetting and drying. To remedy the sulfuric acid, the use of low C3A content to be found and such cement with low C3A, low tricalcium aluminate and comparatively low tetracalcium aluminoferrate content is known as sulfate resisting cement. Remember, in sulfate resisting cement, there is low C3A content, low C3A content, and low C4A content. In other words, this cement has a high silicate content. That means C3S का C2S C3S का amount ज़्यादा होता है. Okay. Tetra aluminoferrate varies normal producement. Okay. C3A2 C3A plus C4A should not exceed 25%. Okay. What is the suitable? The uses of this type of cement can be used in marine condition. Concrete should be used in foundation and basement where soil is infested with sulfates. Concrete used for fabrication of pipes, which are likely to be buried in marshy region or sulfate bearing soils. Next is your concrete Uh, it should be used in a construction of sewage treatment wall. Okay. Next is Portland slag cement. The IS code is IS 55 1989. Portland slag cement is obtained by mixing Portland cement, clinker, gypsum, and granular blast furnace slag. So, diffusion of chloride. Next we have quick setting cement. That means in quick setting cement, we have there is a quick reaction occurs and a setting time reduced. Okay, and a gypsum content at the time of clinker grinding. This cement is required to be mixed, placed gradually, immediately. Okay, and next we have super sulfated cement, low heat cement. This is important. Okay, and I will share these notes to you. And next we will go for different taste of cement. Okay, so types of cement in next class we will discuss about rapid hard low heat cement. Okay. Okay, 30 students present today. Roll numbers. Let me take a click. Okay, thank you everyone.
Okay, thank you, everyone.
It's tomorrow we
It's tomorrow
I will take your
I will take your
surface hydrology class.
surface
Okay.
hydrology class.